Hi everyone, today we'll be discussing the LeetCode problem of the day, valid triangle numbers. In this problem, we are given an integer array nums and you have to return the number of triplets from that array that can make a triangle if we take the numbers as the sides of the triangle. For example, we have the array 2, 2, 3, 4. In this array, we can choose the sides as 2, 3 and 4. So these triplets will make a triangle. So the triangle will look something like this. So this will be side 4 and probably this will be side 3 and side 2. And we have another triplet with 2, 3, 4. Here we have taken this 2, so we can form another triplet with taking this 2, and finally we can also form a triangle with 2, 2 and 3. So this triangle will be like side 3 and then 2 and 2. In this array we can form 3 pairs which will form a triangle. We know that to form a triangle we have 3 sides, A, B and C. For the triangle property, if A is the length of the longest side, then A should be greater than the sum of the shortest sides. So if this property holds true, then we can form a triangle with the sides. This is true because suppose let's say this is A and it's the longest side. And now we can take a side like this and like this. So this is B and this is C. So we can clearly see that in this example B plus C is greater than A. Now what if we reduce the height of this this side? So B will be like this and C is like this. So here as well B plus C will be greater than A, because if we compress this slope, it will extend over the length of the A. So B plus C is always greater than A. And if B plus C equal to A, that means the triangle is like this. We have A here and B will be like this till somewhere like the half point, and we have C from here to here. So if B plus C is equal to A, then this is the triangle formed, but here this is not a triangle because it's just a simple line. So to form a triangle, we can surely say that B plus C should be strictly greater than A, and A is the longest side. Now coming to the approach, like we discussed, based on the triangle property, in the given number array, we have to find all the triplets such that A less than B plus C. Now for this, we can use 3 loops. First loop will iterate on A, second loop will iterate on B, third loop will iterate on C. And once we have A, B and C, we'll just check this formula, and if it's true, then we'll just increase our answer. This will have a time complexity order of n cube, and since n is 10 power 3, 10 cube will be 10 power 9, and this will give us a TLE. We have to optimize the code to reduce the time complexity from n cube to n square. Now for that, we can think of like we have the formula A less than B plus C. For that, we can fix A, and let's say for a particular A in the number array, we can find how many pairs of B plus C which is greater than A. Now for a particular A, all we have to do is find how many pairs of B plus C from the number array, and we can do that using 2-pointer method in order of n time. So for a single A, we use order of n time to find how many pairs b plus c that are greater than a. Now we have n minus 2 number of a's, so the total complexity will be n into n, so n square. Now first of all, let us sort the array, because if we have to use a 2-pointer, we have to have a sorted array. Let's say the array is 2, 2, 3, 4 after sorting. Let's also have a 1. Now we have the formula a less than b plus c. Now let us fix 4 as the a first. So in the rest of the array, that is from this starting to the 3, we have to find all the pairs such that b plus c will be greater than 4. For that, what we can do is we can initialize 2 pointers. First we'll have b equal to here, next pointer will be here. Now first let's check if nums of b plus nums of c is greater than 4 or not. We can see that 1 plus 3 is greater than 4. This condition is false because 1 plus 3 is equal to 4. Now we know that in our current setup, nums of b plus nums of c is greater than nums of a is false. Now since this is false, that means this left hand side quantity is less than equal to the right hand side. To increase the left hand side value, we have to move b forward, because if we move c to the left, the numbers will decrease since the numbers are sorted. So we have to move b forward. Now we will move b to this index. Now if we see that the condition is true, because 2 plus 3 is greater than 4. 2 plus 3 is greater than 4. So 4 is the longest side and 2 is a first side and c is the second side. Now 4 is fixed, it is the longest side, and c equal to 3. This is also fixed, which is the shortest side. For the other side, we can pick all the elements from this b up till c minus 1, because since the array is again increasing, all these numbers will be greater than 2 and this formula will be valid. So we can simply say that for this setup, we can have c minus b number of pairs with 4 as the longest side. So that means we'll have 2 pairs, and the pairs are 2, 3 and 4. This is the first pair. Now we take the second 2, so it is again 2, 3 and 4. Now after this, since b plus c is greater than the longest side, we will decrease the c. So what happens is we do c minus minus. Now again we can see that 2 plus 2 is greater than 4, it is false. So we do b plus plus. So b reaches here and the loop stops. And so far we have found only two triplets. Two triplets with 4 as the longest side. Now this is done, we will move to the previous number. Now see, 3 will be the longest side. So for 3 as well, we repeat the same process. We will have b equal to here, c is here, and first we'll see if 1 plus 2 is greater than 3. The condition is false, so we'll just do b plus plus. Now b will reach here. Now again we'll see b plus c is greater than 3. 2 plus 2, 4, it is greater than 3. So we'll increase the answer by c minus b. So c minus b will just give you 1. So 1 will be added to your count, and the triplet is 2, 2 and 3. And after doing this, you'll just do c minus minus, and since the both are equal, the loop breaks. Now finally, we will move this 3 again further. So now 3 will be here. 2 is the longest side. With 2 as the longest side, we need to find how many triplets that will form a valid triangle. Now b will be here, c will be here. So again we can see that b plus c greater than 2 is valid. 1 plus 2 is 3, 3 is greater than 2. So the answer will be, in the answer we will just add c minus b. So this is 1. That means the another valid triplet is 1, 2 and 2. After adding this, we will do c minus minus, and since it is same, the loop stops. Notice that the longest side will only iterate from the last element till the second index, because if we take the first index, then we can't pick 2 elements from the left, so we only stop here. We only iterate from here to here as the longest side. Now let's go with the code. So we have the formula a is greater than b plus c. So what we can do is, like we discussed, we'll first iterate on the longest side. For int a equal to, and the longest side will start from index 2, a less than num start length a plus plus. Now for this, we need to find b and c. For that we can just use a 2-pointer, int b equal to 0 and c equal to a minus 1, while b less than c. First let's check if the condition is true. The condition is nums of b, I think this is a is less than b plus c. Yeah, so nums of b plus nums of c, if it's greater than nums of a. If it's greater, then simply in the answer we will add c minus b. Let's also initialize an answer variable. Also we need to sort the array before iterating it. So arrays dot sort nums. Now once we increase the answer by c minus b, we can simply reduce c minus minus. Else indicates that b plus c, this quantity is smaller than a, so we need to increase this quantity, and we can do that by increasing the value of b. So this is the 2-pointer, and it will find all the pairs of b plus c which is greater than a, and at the end you can just return answer. And let's submit, and it works. Finally, let's understand the time and space complexity. For time complexity, we are running a loop, and inside the loop we are again running a 2-pointer loop. So this loop will run order of n times, and this also is order of n. So total we have order of n square, and n square will be just 10 power 6, so it will pass. For space complexity, we have just order of 1 because we are not initializing any extra space. For time complexity, we also have order of n square plus n log n. This n log n is coming from sorting the array, but since n log n is smaller than n square, we can just ignore the smaller term. So the effective time complexity will be order of n square. I also have the code in Python. If anyone wants to check it out, I'll add it in the description as well. And let's catch up in the next video.